afternoon, everyone. This video has been made in conjunction with a unit plan featuring 3 to 4 lessons on coding. Today, I will be going through with you a brief description of the overall activity, and then in detail I'll explain how the activity enhances students' knowledge of coding and how the activity facilitates computational thinking. When I'm answering these 2 questions, I'll briefly incorporate the connections to the other key learning areas in the curriculum. So basically, the activity in the unit plan involves students exploring the program Scratch. The students will be given a problem of how to make a rocket ship move to a planet, and then the lessons have been designed to help the students solve this problem by exploring the coding of movement, events, looks, controls, and sensors. The students will also have to develop their mathematical understanding of X and Y coordinates and time to be successful. The challenge throughout every lesson up until the assessment is to make their rocket ship look and move realistically. Okay, so let's dive in to how the activity actually enhances the students' knowledge of coding. Being that this is a coding lesson, it directly influences the children's knowledge. Scratch is a programming language and online community where children have the ability to program and share their interactive media. So things like stories and games and animations, they can share with people all over the world. As children use Scratch to create these things, they learn to think creatively, work collaboratively, and reason systematically. Now that is the computational thinking we were talking about before. It's also in a safe online environment, which is particularly important for the curriculum. Scratch takes all of the essential programming constructs like sequencing, conditional branching, control structures, data manipulations, and wraps them in to a very easy to use environment for young students and can be used with very little knowledge to begin with. It's quite intuitive to learn, and you can do simple things fairly easily, but the best thing about Scratch is that it has really no limit to how far you can take it. It's pretty much limitless for students learning. So let's talk about how the activity facilitates computational thinking. Well, first of all, what is computational thinking? Computational thinking involves looking at a problem and using a digital system to create a solution. When you analyze a problem and plan a solution, you are computational thinking. It's stuff you do every day. Computational thinking focuses on 5 key strategies, which are decomposition, data organization, abstraction, algorithms, and patterns. So let's dive in a little deeper. I'm going to go and show you specifically what parts of the activities link to these 5 strategies of computational thinking. Let's start with algorithms. These things here, the actual coding is algorithms. Algorithms are a sequence of steps, and they're the sequence of steps you use to solve the problem. So closely connected to that is decomposition, which involves breaking a big problem down into smaller parts and dealing with each part separately. This has been shown through the sequence of lessons by breaking down the problem into smaller parts, such as motion and costumes, dealing with them separately. But these will inevitably, when put together, solve the bigger problem. Patterns is all about striving to find the easiest and most efficient way to do something. So this has been shown by finding the most efficient codes in order to solve the problem, as you can see here. The difference between lots of steps of motion and one code that's going to get me from point A to point B. Logical reasoning, also considered data organization, is exactly what it says it is. It's reasoning in a logical way by making predictions to make deductions from the information that they have. For example, if a code isn't working, like you can see here, looking at it carefully and using logical reasoning to explain what you are exactly telling the computer to do can sometimes be the best way to debug your system. Lastly is abstraction. Now, abstraction is the bread and butter of computational thinking. It's realistically just about capturing the important information, but not worrying about the details too much. We've focused on mainly the first layer of abstraction by looking at what exactly a program does.